Okay, next. And this one, we change the page color this time. Yeah, this seems a little bit different. Okay. Now what happens if you are given something very different, okay, which you haven't seen, but they are asking to solve that thing out? If they ask you that, but G is a group where there is a property that square of every element is the identity. So is G an abelian group? See then, so they are saying a square equal to b square, that is ab whole square, that is an identity. So what we have, a square b square equal to ab whole square. This a square is nothing but this, b square is this, nothing but ab 2 times. Let's take the inverse. Every time we do it like this, v inverse, and that is equal to a inverse ab b inverse, just the way it's been given. So now take a inverse and a into consideration, leave ab and b inverse together. Similarly here, a inverse and a together, b a and b inverse here. So this is e ab and e b a and e. Okay, so this ab equal to b, hence G is an abelian group. So you don't have to remember anything. Only by a normal pattern based idea we can solve any kind of group based question over here. New structure. Okay. So in this new pattern I will be solving some special questions. So the very first that we can solve over here is the order based question. So order of the element, first question. Accept identity in rational number with positive values, with positive modulo structure, group of rational numbers under addition. So order of element accept identity in this, the group of relationship, the group of rational numbers under addition. Option A, always finite, always finite, always infinite, always 0 and always 1. So let's see, they're saying that in Q, x plus x dot 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 x equal to 0. That is itself x equal to 0 because it is nx, n times 0. So in Q, number of elements in this structure is 1. So all other elements have infinite order. So the answer to this question is B. Next question is, now what MCQ type you can expect. So if the order of an element in a group A, if order of an element A, order of an element A of group G comma dot is n. So the order is n with identity element E. Then which one is correct? M. So M is any integer and D is, and M is any integer. So which one is considered applicable? So what is happening over here? Here we can say that let A belongs to G and has the order n. So A to the power n equal to E we can say very easily. So AB equal to A, where B is the inverse, such that this thing is happening. So B is nothing but A inverse. So B to the power n is A to the power minus 1 n. So A to the power n of minus 1, that is, this is E as well, we know. So E of minus 1, which is nothing but E, because in the inverse of an identity is the inverse. So the order of B is also n. So the order of B is also n. Hence this, in this case we can say that A may be correct, B may be correct, or D may be correct. So multiple options can be correct type of question can also be dealt in this way. Next question is, they have given A, B, C are group elements where number of elements of A is 6, number of elements of B is 7. Then A4 C to the power minus 2 B4 whole inverse can be expressed as option A, C, A square, or option D, B square, C square, and A. So what we have, this is 6, so obviously A to the power 6 is E. That can be given as A4 A square equal to E. So A4 is A square inverse, that is A to the power minus 2 E by A square. Similarly B4 will be B to the power minus 3. So similarly A4 C to the power minus 2 and B4 whole inverse will be equal to A minus 2 C minus 2 BQ, that of minus 1, now it's matching. So B of to the power minus 3 of minus 1, C of minus 2 of minus 1, and A of minus 2 of minus 1. So this is equal to BQ C square A square. This is nothing but B of minus 4 C of square A of minus 4. So this thing is coming. Hence in this case if we see that option A can be correct, so does option number B. So this is a way we can solve some questions. In our forthcoming video I will be focusing on only on solving questions on group theory based idea.